All right, we're going to continue with our series on research methods. In this lesson, we're going to start talking about variables and the different kinds of variables that we have, operational definitions, what they are, different types of relationships one can have with research in terms of correlation, positive, negative, curvilinear, and no function. Then we'll compare non-experimental methods with experimental methods. And then we'll talk a little bit about reliability and validity. All right, so let's start with our concept. What is a variable? Well, when we look at the word variable, the root of the word variable is vary. So a variable is any event, situation, or behavior that can vary. Now, for those people interested in English and literature, one of the cardinal sins in definitions is to use the word as its definition. So a better way of saying a variable is anything that can assume two or more values or levels is considered a variable. Now, variables can be qualitative or quantitative. Qualitative tends to be categorical variables, things like gender, ethnicity, political party. These are categorical variables, but variables can also be quantitative, things that we can measure or assume numerical values. So let's talk about the four general categories of variables. One category is a participant or subject variable. These are individual differences that our participants bring into the study with them. So a person has a gender identification, has a relatively stable personality, has a relative level of intelligence, an ethnic category, an age, and so forth. All of these are considered participant variables. These are not to be manipulated, but they can be measured alongside other variables. We also have situation or situational variables. These are characteristics of the situation or environment. So the situation variable is oftentimes in an experiment linked to the independent variable. So we can manipulate the independent variable. So examples might be word length, class density, credibility of a person, and so forth, right? These are situations you expose your participants to. We also have response variables. These are your behavioral output or your performance on a task. So the response variable is oftentimes linked to the dependent variable in an independent study. However, there is a fourth kind of variable called a mediating variable. And a mediating variable is a psychological process that can mediate the relationship between a situation and a response. And the most common example that's given is diffusion of responsibility. And the research on diffusion of responsibility comes out of a tragedy with Kitty Genovese. The story goes that nearly 36 people observed her murder and no one called the cops. And the perpetrator of the crime came back 3 times over a span of, I guess, a half hour to an hour, but no one called the cops. Many people observed it. And the question was, why didn't people call the cops? And the concept was diffusion of responsibility. Each person said, well, I don't need to call the cops. Maybe someone else is going to call the cops, or maybe someone already did. So Darley and Latané did a series of studies where they looked at the relationship between number of bystanders and helping behavior. And what they found was as the number of bystanders increased, helping behavior tended to decrease, whether it be a smoke-filled room and getting help or calling attention to the researcher that, hey, there is smoke coming through the vents, or any number of other studies. Now, why is it that as the number of bystanders increases, helping behavior decreases? Well, let's just think about it this way. If you are the only observer to a situation or an instance where people need help, if you're the only person, you have 100% of the responsibility to act. Because if you don't act, then there's going to be no help on the way. What if you have one additional person? Well, now that 100% of responsibility is divided amongst the two people who are observing whatever is happening. So now your level of responsibility drops to 50%. If there are 3 observers, now your responsibility drops to 25% because there's 3 observers plus you, that's 4, right? And as the number of additional bystanders increases, your responsibility to help drops. So in the original reporting of Kitty Genovese, there were allegedly 38 people who observed. And that means that your relative responsibility is a little over 2.5%. So you would easily say the vast majority of responsibility falls on other people. So as a function of that, psychologically, you say, well, I'm not responsible. And that is what diffusion responsibility is, that the responsibility of helping is spread out amongst all of the bystanders. And that's important to think about, right? Now, as I said, Darley and Latney did several studies on this, and they did find consistently as the number of bystanders increase, helping behavior among the bystanders decreases. And that's pretty crucial. So that's an example of how a psychological principle such as diffusion responsibility, saying, well, I don't have responsibility to help, or have a small fraction of responsibility, or maybe someone else might be more capable of helping. All of these things are called diffusion responsibility. You spread it out to other people, and that results in you not helping as the number of bystanders are there. Now, so those are the kinds of variables. Now, it's important to also talk about the concept of an operational definition. An operational definition is a specific definition on how you're either going to measure or manipulate a variable. What techniques are you going to use to measure? What are you going to manipulate? Now, some things are easy to define in terms of operational definitions. For example, we talked about word length. Well, you could talk about word length in one of 2 ways, and they're both tangible. Number of letters in a word or number of syllables in a word. That's very easy. But there are other concepts that are a little more abstract and can be a little more challenging to define. Things like intelligence. How would you define intelligence? Well, the most concrete way to define intelligence is your performance on an intelligence test. But if we look at psychological science and the research on intelligence, there are many competing definitions and theories about what intelligence is and how it should be measured, going all the way back to Binet and Thurstone and Cattell and Howard Gardner. There's so many theories about defining intelligence. So when it comes to the more abstract concepts, you need to be much more specific about how you personally are going to define intelligence. So that if a person disagrees with your definition, that's okay, but at least they're clear on it. So if I were to say I am defining intelligence as scores on the Wechsler intelligence scale, well, that's very clear. The reader knows how I defined it. Even if they disagree with me, it's concrete now. So we took a very theoretical concept and made it more tangible. So as I said, there are variables that have different levels of abstraction. Word length is very easy, as I covered. Stress is a little bit more abstract. How do you define stress? Is it your response on a survey? Is it your blood pressure? Is it your heart rate? And so many others. There's so many ways to define stress. But if you're going to define stress, you need to tell the reader how you're measuring stress. Now, to actually do studies or science, it's so crucial, this concept of operational definitions. And in order to do an empirical study, we have to make the abstract more tangible. We have to clearly define how we're manipulating or measuring a variable. Now, as it relates to word length or stress, these are oftentimes dependent variables, but we can also manipulate an independent variable, right? Something like speaker credibility. How do we define speaker credibility? Well, we might have an essay written by, quote, a Nobel Prize winner and compare that to an essay written by a substitute teacher, in quotes, and compare the relative endorsement of the things said in that essay. Well, the higher rates of endorsement would reflect greater credibility. But notice how we're manipulating at baseline, even before we give the essay and they read the essay, we're manipulating who wrote it. So we have to be clear both on the dependent variable and the independent variable, how we're measuring and manipulating. So it also helps us communicate our ideas with others. So if I wanted to know about aggression, I need to know what people are talking about. So in a Bandura study, we might look at how many times a kid punched an inflatable clown. Or I might look in school psychology research, aggression, how many fights a kid got into during recess. Or if I was looking at large scale, data from crime statistics, I could look at homicide statistics or aggression, the tendencies for aggression on a personality test. But notice how when we first started talking about aggression, it started out very vague. But these 4 examples make it much more clearer, and it makes it easier for us to agree on the term and how, by describing how it's being measured. Now, it's important to understand that with most psychological constructs, there is rarely one infallible method for operationally defining a variable. As you saw with aggression, there were 4 listed, and that was just an example. With word length, there were 2. So we must think about how we're measuring manipulating variables, and we must take into consideration other factors like, what is our research question? What's the ethical considerations of doing this research and the cost of experimentation? And in a later lecture, I believe it's chapter 9 in the Cosby and Bates book, we're going to talk about the practical side of doing experiments, things like the cost of experimentation. So, because there's no single method that's perfect, it's best to study a variable using many different forms of operational definitions. And the more consistent the outcomes, the more confidence we have in that outcome, right? So we talked about reproducibility, and nothing is ever proven, but we can have greater confidence in an outcome if we measure the same construct over and over and over using different operational definitions, and it comes to the same conclusion. So the next thing I'm going to talk to you about is the relationship between variables. So whenever we hear the term relationship, think association between variables. The most common term is correlation. Correlation is the most common term we use. Now, when it comes to correlation, there are different kinds of correlations. There's a positive linear correlation. There's a negative linear correlation. There's a curvilinear function, which a Pearson correlation can't measure. And then there's the concept of no correlation. Now, when we talk about the concept of a positive linear relationship, the word positive in this particular context is not a value judgment. We're not saying it's good or bad, so positive isn't necessarily good. What we're saying is that the variables go together in the same direction. What do I mean by that? As variable A increases, variable B also increases, or as variable A decreases, variable B also decreases. So both have to either increase or decrease together. That's what we mean by positive. Negative means that we have an inverse relationship. So as variable A goes in one direction, variable B goes in the opposite direction. A curvilinear function means as variable A increases, variable B goes up and down in a systematic way. So there's both increases and decreases in a systematic way. It's very important to understand that the increases and decreases are systematic, and you could see almost like a bell-shaped curve. Whereas no relationship, you have increases and decreases on variable B, but it's in a random fluctuating way. So these are the four relationships. Now, there are many examples of a positive correlation. So a positive correlation might be the more you study, the higher your test grades. Right? That makes sense, right? The more hours you invest in your preparation, you're more likely to perform better. Similarly, the fewer number of hours you put into your studying, the likelihood on average is that you're going to get a lower score. So notice how your scores on a test and your scores or the amount of hours you study go together. A negative correlation is they're going in opposite directions, as I said. So a good example might be the cost of gasoline prices and the number of miles you drive per day. So as gas prices go up, you're more likely to be more conservative and drive fewer amount of miles. Curvilinear function, many things are on a curvilinear function. All naturally occurring phenomena approximate a bell curve. So examples include intelligence, personality, height, weight. All of these are on a bell curve when we put all the scores out. And then no relationship. There is no systematic connection between the factors. So an example might be your shoe size and intelligence. So you can have a really large shoe size and have large or high IQ, average IQ, or low IQ. You're not going to find a systematic connection. So here is how a positive linear correlation looks like. So you'll see positive linear correlation goes upward to the right. A negative linear correlation goes slope downward to the right. A curvilinear function is like a bell curve. It goes up in a systematic way and down in a systematic way. And no correlation is actually depicted in two ways. The most common way is on the slide, which is a flat line. But there is another way to depict no systematic relationship between variables, which is just drawing a circle around the scatter plot or dots. So whether it be a flat line or circle, these are the two ways to depict no relationship. Now, monotonic and non-monotonic functions. The word mono as a prefix means one, right? So a monopoly is one person who has a lot of real estate or has disproportionate power in an area. Monotonic means that the graph goes in one direction. So whenever you have a linear function, whether it be positive or negative, that would be a monotonic function. Now, you also can have nonlinear functions which are still monotonic. Now, look at my hand. If you go up and then you go flat across, it's still considered monotonic because there was never a change in direction to a more negative point. So as long as the graph goes up or down and never changes direction to a more negative or positive direction, then we say it's monotonic. As soon as the function changes direction from a more positive to a less positive number, then we say it's non-monotonic. Now, in correlations, you'll see a Pearson R, the lowercase r, which we'll talk about later in lecture 12. It goes from 0 to 1. Now, I say 0 to 1 because we're looking at the absolute value of the number. Now, we already talked about positive and negative. So positive and negative are the direction of the function, the direction of the relationship, but the actual number can only go between 0 to 1.00. If the number exceeds 1.00, it's a typographical error. And as I said, we're looking at the absolute value. So the closer we get to 1, the stronger the relationship. So let's say you had a negative 0.92 correlation and a positive 0.88 correlation. Believe it or not, the negative 0.92 correlation is actually stronger. Why? Because if we ignore the sign, which only tells you direction, 0.92 is a higher number, a larger number than 0.88. I hope that makes sense. Now, the next thing we want to talk about is reducing error. So in all studies, we want to reduce the amount of error variance, error variability. So the smaller amount of error variance we have, the better things are. And we're going to talk about small error equals greater consistency, greater reliability. So the more we have error, the less we have confidence in our outcomes. The more systematic the relationship is, the less error we have and the more confidence we have. So, and I'm going to come back to that in a later point in the lecture. The next thing I want to talk to you about are non-experimental versus experimental methods. A non-experimental method is a study where you're not manipulating an independent variable. So non-experimental methods include what we talked about in our first lecture, observational strategies and correlational strategies. So a non-experimental method, you're not going to be able to determine cause and effect, but you can do other things as we will talk about. So in a non-experimental method, we're looking at the relationship of factors, and the stronger that relationship, the greater the correlation. So That's the emphasis of correlation as a non-experimental method. But observational strategies are also non-experimental. So if you're doing a naturalistic observation, or you're doing a systematic observation, if you're doing physiological response or looking at public record, and you're observing them, that's not experimental. Now, what are the problem? What are the weaknesses in non-experimental method? I'll show you. There are two problems: the issue of cause and effect and confounding variables. So the strongest of the non-experimental methods is a correlation. But let's say we had two factors that we know are linked: low self-esteem and depression. Is there a relationship between the two? Yes. Low self-esteem and depression are strongly connected. However, let me ask you a question. Which one causes the other? So if we have a correlation, we can't determine cause and effect, because in some cases, it was the low self-esteem that led to the depression. And in other cases, it was the depression that led to low self-esteem. So which one came first? It's a chicken egg problem. We don't know. And in order to have a cause, as we said in lecture 1, the cause must always precede the effect, which we refer to as temporal precedence. In addition to the chicken egg phenomenon that we don't know which one came first, there is an infinite number of outside factors that could have also led to this outcome. For example, are there other factors that could lead to both low self-esteem and depression? The answer is yes. For example, a trauma. If a person had a physical or a psychological trauma, that could lead to depression, and it could also lead to low self-esteem. And this third variable problem, or also known as confounding variables, you can't get rid of in non-experimental methods. You don't eliminate the confounds, you don't eliminate the alternative explanation, so you're left with the third variable problem. So that's a big issue. You can't determine cause and effect. All right. Now, the experimental method, on the other hand, you have direct control over your independent variable, your dependent variable, and you can actually control outside factors such as confounds. And let me explain. The independent variable, you are going to manipulate. So you have control over that particular variable and the levels or conditions within the independent variable. The dependent variable, that's a variable you're going to measure. And you eliminate confounds using systematic control and randomization. Systematic control means that you're going to treat all participants the same. So if you treat all participants the same on a given factor, that factor cannot result in differences in an outcome because everyone was treated the same. So you've controlled for that. However, there are some factors you cannot treat the same. Earlier in this lesson, we talked about participant variables. You are who you are in personality, age, gender, ethnicity, and your experiences. Can I sort of, like Men in Black, just zap your memory like you don't remember anything? No, of course not. So for the factors we cannot treat you the same, we have to neutralize through randomization. And randomization occurs through random selection, who is included in the study, and random assignment, how you're put into groups within the study, whether you're put into the experimental condition of the independent variable or whether you're put in the control condition of the independent variable. So that's random assignment. And if you have a large enough group, random assignment neutralizes the effect of participant differences. So we talked about experimental control. That's holding everything constant. So I said this already, if you hold a variable constant, it can no longer be a confound. That happens when we treat each group identically. And the goal with experimental control is the only factor that you should differ on is our independent variable, our manipulation. And if the only factor you differed on is our manipulation, then we can say that it was our manipulation that led to this outcome. That discussion, although it may not seem connected, is linked to what I said was covariation of the cause. In the presence of the cause, you get the effect. In the absence of the cause, you don't get the effect. So if we've neutralized every other factor but our manipulation, and we get differences between our experimental group and our control group, then we can say we have a causal relationship. Now, randomization, like I said, we have to neutralize certain factors like participant factors, and we do this through random assignment. Now, how do we determine who gets put in an experimental group or a control group? Well, you could do it in many different ways. A person could sign up for a study, and using SurveyMonkey or Qualtrics, you can set up a randomizer, which the computer randomly generates a condition for them. Or in a paper-based survey, you could use a table of random numbers and go down or across. And if they're odd, if the number is odd, that person goes into one group. If the number is even, they go into a different group. So there are different ways to randomize. So here is a summary between non-experimental, experimental groups, examples of what they are, advantages and disadvantages. Now, I said in an experiment, the independent variable is the variable you manipulated. That is oftentimes referred to as the cause, right? Or we want it to be the cause. Now, at a minimum, an independent variable, to be a variable, I said earlier in the lesson, you have to have 2 or more levels or conditions. So a basic experiment, the independent variable has at least 2 conditions. The experimental group that gets the manipulation or treatment, and the control group that gets nothing and serves as a comparison. The dependent variable is a variable you measure. This is oftentimes referred to as an outcomes variable. It's called the outcome of the manipulation. It's also referred to as an effect. In a basic experiment, you have 1 dependent variable. And you're probably wondering, well, why did I say in a basic experiment you have 1 independent variable, 1 dependent variable? Because there are more complex experimental designs where you can have multiple independent variables and or multiple dependent variables. Now, here's how you would graph an independent variable and dependent variable. The x-axis, you always put the independent variable on the x-axis. The y-axis, which is vertical, you always put the dependent variable in an experiment. Now, if you have multiple independent variables, you're often going to see a box at the top right where it has that second variable and a legend or key that explains it, and then you'll interpret it that way. So when you have multiple independent variables, one goes on the x-axis, one goes within the box. So causality, we talked about this already, but in order for the experiment to have cause and effect relationships, you need temporal precedence. The independent variable must precede the dependent variable. The cause must precede the effect. So before you introduce your independent variable, there should be no differences between the groups. However, upon introducing the independent variable, you should get differences as a function of the independent variable. So temporal precedence, temporal means time related, precedence means before, to precede. So the independent variable must precede the dependent variable in time. Covariation of the cause means that in the presence of the cause, you get the effect. In the absence of the cause, you don't get the effect. Now, typically, I said the independent variable has a minimum of 2 levels. Well, the experimental group is going to be the treatment. The control group is going to serve as a comparison, right? So we can see the presence of what we believe to be the cause and the absence of what we believe to be the cause, because in an experimental group, the treatment will be present. In a control group, the treatment will be absent, and we expect differences between the experimental and control group. However, that's not enough. Temporal precedence and covariation of the cause is not enough to say we have a cause and effect relationship. We need more. All true experiments require randomization. You have to randomly assign people into groups, and you have to engage in experimental control. The purpose of that is to eliminate alternative explanations or to eliminate confounds, as we talked about in our first lecture. So right now you're like, whoa, an experiment has so many advantages over non-experimental designs. You can determine cause and effect. You can explain. You have greater certainty in your outcomes. So why not just use an experiment? Well, here is a list of all the considerations you have to think about and reasons why a person may not use an experimental design. So let's go through them. Artificiality. When doing an experimental design, in order to have cause-effect relationships, the experiment must be carefully controlled, airtight. And because of that, it happens oftentimes in a lab. Now, there are field experiments too, but many times what happens in the lab doesn't generalize out to the real world. There's a sense of staleness or artificiality, and because you have such airtight control, that doesn't mirror everyday conditions. So if a person was trying to mirror real life, they may not do a lab experiment. Now, I did say that there are field experiments. Now what's happening is your manipulations happen in a real world. One challenge with that, though, is you don't have as much control, and you have the potential for confounds. So you have a dilemma whether to use a true experimental design in the lab, which is artificial, a field experiment, which you have less control, which interferes with your cause-effect interpretation, or to do a non-experimental design. The choice is yours. Now, I'm going to say something now that is going to be useful at a later point. But when we talk about lab experiments that have greater internal validity, field experiments have greater external validity. All right. Other factors that one must consider when doing a study are ethical considerations. So some studies you cannot manipulate. So we have to use an ex post facto or a quasi-experimental design. Ex post facto means after the fact. So let's say you were studying divorce, right? You can't manipulate divorce, right? You can't say, sorry, I have enough married people and you need to get a divorce. You can't force a person to get a divorce. Or, sorry, I don't have enough married people, you need to get married. That would be unethical. So what we do is we take people who already fit into a given category and we compare differences between outcomes, married versus divorce, let's say on happiness or whatever. Other things that we have to think about are participant variables. Participant variables can't be manipulated. Things like age. Your chronological age is your chronological age. I don't care how much Botox you get. Your age is your age is your age. Gender. Your gender, how you identify is how you identify. I can't force you to identify other than how you identify. Your ethnicity is what it is, what it is. nationality, marital status. You get the idea. So participant variables are personal variables. You can't manipulate them. You just study them alongside an independent variable. Now, other reasons why you might not use an experiment. You might have one goal, and your goal is to just merely describe behavior. So if your goal is to describe behavior, you don't need an experiment. All you need is a good observational study. And if you're wondering, well, maybe an observational study is not that useful or whatever, there are great findings that occurred as a function of careful observation. For example, Piaget, his cognitive stage theory of development occurred due to observing his children carefully. And it's one of the most influential theories in developmental psychology. Another reason why you might not do an experiment is because you're only trying to predict an outcome. So if you were an employer, if you were a college admission team, you might only want to know, is this person going to be successful at the job or at the university? And you don't care why they are, you just want to predict success. So you might give a test that allows you to predict an outcome. So with a correlational study, it allows you to predict success, and that's sufficient. For example, if you were an owner of a used car dealership, and you're hiring a new salesperson, and you gave them a personality test, do you care why the person is predicted to do well at selling cars or not? Probably not. You just care more about the bottom line. It's us psychologists who care about personality factors like introversion and extroversion and how they affect you in certain occupations. So, as we've said before, though, similar to operational definitions, there are many ways to define a variable. There are many ways to study a variable, many designs. So no single method, whether it be an experimental method or a non-experimental method, is going to give you a full picture of a phenomenon. The best way to capture a phenomenon is using multiple methods. So we use non-experimental methods alongside an experiment to capture more information about the phenomenon. So the next thing I'm going to talk to you about is reliability and validity. Reliability refers to a consistency of a measure. Validity refers to the accuracy of a measure. So reliability is if I give this test over and over and over, will give me a predictable, dependable, or very similar outcome all the time. Well, here's the deal. We know that every single instrument has some error. The test you will take throughout this term has some error, but the goal is to assess the true ability and error. And we want most of your performance to be based on your true ability, and we want very little to be based on error. So all observed scores are a combination of your true ability plus error. And the more reliable a measure is, the less amount of error is going to have. We know that all instruments have some error, but we want as little error as possible. Now, an unreliable measure is fairly useless. So if you get on a scale 3 times in a day and one time it says 120 pounds, another time it says 150 pounds, another time it says 135 pounds, it's not likely that your weight fluctuated in reality that much in a given day. So you might question whether the scale is actually functioning properly. So when you have an unreliable measure, the outcomes are useless. So you want to make sure that the instruments you're using are consistent. And if that's observers, you want to make sure that the observer scores data consistently. If you're doing an interview, you want to make sure how questions are phrased to make sure they're phrased consistently. If you're doing neuroscience, you want to make sure the electrodes are placed consistently in the same place of the brain. Now, as I said, in reliable measures, you want as little error as possible. So the top bell curve that's skinny, that is a more reliable measure. The more spread out the bell curve is, the more error there is. So I'm gonna stop there because I already made another video that covers some of these concepts, but let's stop here and I'll share both of the videos with you.